Hello and welcome back to Upgrade to General, a series to help you upgrade your amateur radio license to General class. This episode is subelement G4, question group E, about mobile and portable HF stations, alternative energy source operation, and I'm your host Ron Call, KE7CR. So let's get started. The first question says, what is the purpose of a capacitance hat on a mobile antenna? A capacitance hat is a series of wires that extend from the tip of the antenna or somewhere along the antenna, and the purpose is to electrically lengthen a physically short antenna. One of the major problems with mobile or portable antennas is they're just going to be very long, very large to operate from portable situation. So to electrically lengthen them to allow radiation on the bands of interest, you can imagine 80 meters, 40 meters, it's going to be extremely difficult to operate a full-size antenna in a portable situation. So the purpose of a capacitance hat is to electrically lengthen a physically short antenna. Next question, what is the purpose of a corona ball on an HF mobile antenna? The purpose is to reduce RF voltage discharge from the tip of the antenna while transmitting. If it discharges at the tip with a spark, that's going to be bad. It's going to generate a lot of unwanted frequencies. So having a corona ball helps it to not discharge from the tip of the antenna while transmitting. Next question, which of the following direct fused power connections would be the best for a 100-watt HF mobile installation? The best connection is directly to the battery using heavy gauge wire, thick wire, because it's going to carry a lot of current. If you think about this, using Ohm's law and Watt's law is power equals current times voltage. Ohm's law, voltage equals current times resistance. So if we take 100 watts for the radio output and divide it by 12 volts, that'll tell us how much current, and we come up with over 8 amps of current. That's a lot of current, so you need heavy gauge wire, thick wire to carry that current, and you don't want to have any other connections in line with that. It's best to go direct to the battery. The next question asks, why should DC power for a 100-watt HF transceiver not be supplied by a vehicle's auxiliary power socket? The problem is that may not have the capability of carrying that much current. So the answer is the socket's wiring may be inadequate for the current drawn by the transceiver. The next question, which of the following most limits an HF mobile installation? The biggest problem is having a full-size antenna attached to a vehicle is not really possible. So when we shorten the physical length of antennas and try to use coils or capacitance hats or something to electrically lengthen them out, it's going to decrease the efficiency of the antenna. So the answer to this question is the efficiency of the electrically short antenna. That's what most limits an HF mobile installation. The next question says, in what configuration are the individual cells in a solar panel connected together? Each solar cell does not generate that much electricity. Pretty low voltage, not a lot of current capacity, so you connect them in series to multiply the voltage and in parallel to increase the current capacity. So the correct answer here is series parallel. It's a combination, series parallel combination. The next question, also about solar panels, asks, what is the approximate open circuit voltage from a fully illuminated silicon photovoltaic cell? And the answer is 0.5 volts. A half a volt is what you get from each cell. The next question asks, why should a series diode be connected between a solar panel and a storage battery that's being charged by the panel? Diodes prevent current from flowing in both directions. It only allows current to flow one direction. So if you're using that solar panel to charge the battery, you want the current flowing from the panel to the battery, not from the battery to the panel. So the correct answer is to prevent discharge of the battery through the panel during times of low or no illumination. The next question asks, what precaution should be taken when connecting a solar panel to a lithium iron phosphate battery? Lithium iron phosphate batteries are excellent batteries for charging and discharging. They store a lot. They're becoming very popular for portable operations. And the correct answer is the solar panel must have a charge controller. Charge controllers regulate the speed at which the battery charges and it prevents overcharging. Charge controllers become necessary for lithium iron phosphate batteries. That's the last question in this set. Hopefully this was helpful to you, and I look forward to having you join us for the next episode. 73, this is KE7CR.